So the name of my talk, like Eric said, is how a startup survived the hype years of NoSQL. And the hype years here, I'm considering the period of 2010, 2012. That's the period that I remember a lot of articles in Hacker News and other places, a lot of being said about NoSQL. And before continuing, I just want to briefly talk a bit about myself and say that I've been working with Erlang for the last 5 years, and it has been like slightly over a year that I've been working at Kivra. So I was not there from the inception. I can just see what is now there and have and ask some people around and kind of see the history. But one important thing for this talk is a bit which is a bit the motivation as well, is that I have been mostly experienced, or I am mostly experienced with relational databases, especially with regards to problem solving. Okay, I've worked with other types of databases, but I was not the main designer. So arriving to Kivra, I was always wondering, why Riak? Why Riak? And why is this database still here? How this initial architecture survived? But I need to talk a bit about Riak, right? So Riak is a key value distributed database. It's inspired by the Dynamo paper and promises high availability. I think it's more than a promise to actually deliver. The nodes are organized in a ring, and all of them have the same role, which is one of the things that contributes precisely for the availability. There's no leader that would be a single point of failure. Then there's the promise to scale. With the more nodes you add, actually it's true. It's easy to operate, and is usually used as an eventual consistency system, which means that reads may not reflect the most up-to-date version of the object. And now I need as well to talk a bit about Kivra and to say, to explain what is a digital mailbox, right? Because not all of us may know what it is. So imagine the letters that you receive at home, right? So, and how do they arrive there? So you have all these senders that want to send letters to you, and they need to print it and they need to send to post the delivery, and those will be sent to you. And here in between this, we can have some printing partners that will take care of printing them, and actually then they can go to the post delivery. What about a digital mailbox? Okay, so the job of the senders, it will end the moment they generate this file that will be printed, let's say PDF. Then they will send it to Kivra, and Kivra will make it available to Kivra's users through the apps. And basically the data lives safely at Kivra, and it's always available as long as the users have internet, of course, because there's no offline mode, which is not important for this. Okay, so now we know what is Riak briefly, we know what's the digital mailbox, and now the question is, was this NoSQL database a good fit? Was Riak a good fit for the problem? Okay, so let's think about the data, right? The data we are about to store, that my colleagues were about to store when we were thinking about this. And the data is immutable, right? Letters are immutable. And there's other types of data like configurations. They don't change very often, which turns out to be a very good thing in Riak, because being an eventual consistent system, if the data doesn't change, then, well, it minimizes the chance of conflicts. They will still happen. They can still happen in theory, because data can be changed concurrently. But it's not a very highly concurrent system that would be otherwise a problem. Then there's this other requirement that we can't lose data. We can't lose the letters of our customers. So then they need to be stored safely. And Riak is quite safe. And also on this topic, since Riak is available and is available, always available to write, it can tolerate writes even on failure scenarios, we can accept the data from our senders as well. So they are sending the data to us and we are accepting it because Riak, well, at least it won't be because of Riak that we won't be accepting the writes, which is, it's very good. Then the other thing is, well, if we go back and when a company is on its inception in the beginning, there's a couple of things that I would say that they are needed. One is be able to go quickly to try out and to change things, right? And I think a database that doesn't have a schema or doesn't enforce a schema, it may help. More on that a bit later, but that for me, it's a good fit, and as well a dynamically typed language, which Erlang is. And the other thing is, when you start, you don't have any customers, right? You have the sales department working, and then you don't know if you will start immediately with 10 million users, and also letters, they accumulate, right? So it's not immediately you have like 1 million letters, it takes time. So it's hard to know upfront how much capacity will be needed. So it kind of fits a database that you can scale, add more nodes, and you have more storage capacity and more compute capacity as well. Then the other thing is the easiness of operation, right? It's a small team. Databases used to be in 2010, 2012, not as relational databases, I mean, not as easy to configure the high availability modes and things like that may be needed. So I think that Riak was a good fit for the problem, and is still nowadays a good fit for the problem. But now, what about challenges? Were there challenges? Yes, and there's like first one is that Riak doesn't scale well with the large objects. But turns out that the solution for this is quite simple, right? You just need to chunk the files, right? To store them. So instead of storing one object in Riak, that would be 2 megabytes in this case, we store like 4 chunks of it, which it's simple and works quite well. The other one is the absence of schema. Okay, why is this one a challenge? Well, there's still a schema, even though the database doesn't enforce it. There's still a schema somewhere, and I would say that the schema is in the code, is the expectations that the code has. My colleagues figured this out, that there's a schema still, and they did like something that I find quite interesting. That is, they made a dynamic migrations of the data. So let's imagine this case, the object started with just having a first name and a last name. And on a version 2, we want to have this with name, but we already have data on the database that has first name and last name. And will we go over all the objects that we have and then try to combine them? That's a solution, of course. But Riak is made to do accesses with the key, with just one key, and doing all these things in an atomic way. It's not that easy. So then it's what we do is on read time. So we store together with the object, we store the version, and on read time we check, does the version of the stored object match the one that the code expects? If not, it will apply a migration, and it will go and combine, in this case, first name and last name with name. And if there's even one more versus that's not it, okay, we need to apply even one more because the object was in a even older version, like the first one, if it's the version 3, then it applies. Imagine in this case was to add a property called email verify. So there will be objects that were written already in version 2, some were stayed there untouched, and then they are read and they need to be up to version 3, others that are in version 1, and others that are already written with version 3. And this turned out to be a good solution for the problem. And then secondary indexes. This is a fun one. Riak has secondary indexes that are stored with an object, and they are stored in each of the nodes. So to access these indexes, it needs to all the nodes potentially, not all, but most of them need to be contacted. It's not like a simple access with key, and this didn't scale well for us. So especially for cases that they are used very often. So for those cases, we had to implement our own indexes using other objects in Riak. So we have an object for object itself, and then we have for the indexes of that object, we have a separate one that has that. And this turned out to work quite well. It's quite fast. As the problem that one write now is 2 writes or 3, or because we don't use just one, we can have multiple indexes. So in multiple objects per index, we need to have an extra object. And this leads me to the third thing. Leads me to the third thing that is the atomicity guarantees. That Riak guarantees atomicity on key, a single object. And like I was saying, for instance, the index, imagine that we have like one API call that will do a write of a user object, and that needs to write 4 things, some indexes and maybe some other things. And what happens if we have a failure? Well, if we have a failure, then since these objects are already written, so the object itself plus some index, then in this case, we are in an inconsistent state. So, well, there's no transactions, so this really can't be solved. And what was the solution that my colleagues found for this? So what they did, which I think it's interesting, is following a bit Erlang's let it crash, is we let this happen, we embrace it, and we have some integrity checks that will verify if some of these inconsistencies exist, and then try to fix them, some of them automatically, and others they need to be recovered manually. But since Riak is so stable for us, or has been for us so stable, this rarely happens. The only instance that we had problems where we were actually doing a lot of writes, because it was one API call that was demultiplied in like thousands of it, and that one we actually broke out of Riak. We didn't store it there because it was not a good fit. And I have some final notes, and my notes here are the first one is about availability, and that availability matters more than one might expect. And why do I bring this one? Why? So think about Kivra and the letters. You have letters at home. You don't have them always available with you, right? So why would somebody expect that that the service that has a digital mailbox will always be available? Why do people need always to check their mail? they don't, right? But turns out what we observed is that short outages of minutes, there's people trying to check their mail, and they become like hangry, and they leave bad reviews. For instance, they can leave bad reviews. So actually having these guarantees, using a database that has this kind of guarantees, it's quite good, and try to preserve that availability, and try to the other pieces as well to be working. Not only the database, the other ones need to be there. Yeah, and the other one that I have is with regards to hype. So hype technologies, is hype a good thing or a bad thing? I think that it has a bit of both, because hype may put us in a position that we will try some new technologies because we heard about them, right? But hype as well can obfuscate the reasons why we use certain technology and why we are using it. And then if we just use a technology because of hype, then are we in a good position? I don't think so. And another thing is that not all the hype technologies will stay. And some of them, they really have merits, and and I believe Riak is one of those. And it with what happened to Basho, things went into an incognito position at some point, but then they got well. But those kind of things can happen. But that was not necessarily a technical thing. But some technologies may be there one day, and the other day just completely lose traction, and then yeah, not all of them will last, basically. And the last note that I have is that, and this is the main, I would say, main takeaway, because this is what I kind of learned, is that, well, there's no problem of using a hype technology. Hype is, as I was trying to hint, is not necessarily a bad thing. As long, I think what we need to keep in mind, and what we need to try as much as possible, is to understand the technology, understand the requirements, understand the problem that we're trying to solve, and then verify if it matches. And if it matches, give it a try and use it. If it doesn't, just use something else, or use something that you are more comfortable with, and then you'll know, and you won't have like surprises. So that's it. This is what I learn by analyzing Kivra's history and analyzing their usages, and seeing that the initial architecture remains untouched. And I think it's because my colleagues made a good assessment of the technology and the problem. Now I am more than welcome to hear your questions.
Great stuff, Alexander. Thanks for sharing the story. And I'm looking at the Q&A here, and we don't have anything in the Whova app, but I have a sort of a follow-on question, because I know that you have recently launched digital receipts, which is a great service. I'm a user myself, both of the digital secure mail and the digital secure receipts. How did that change the requirements when it comes to database usage and so on and so forth? What have you seen so far?
So with regards to digital receipts, so they started, and they are not in Riak because they started outside. They were done in a collaboration with a separate company. So it's something that we will now we'll now start looking at that to try to make it more uniform, the architecture. But we didn't start with that. But I believe that a receipt is also immutable, so it would be it fits. It still fits the same concept. So the fact that it's not exactly the same architecture is not a technical thing per se.
Okay, thank you. We have a question in the Huba app here. Would you still use a relational database instead of NoSQL database for write-intensive workloads like instant messaging or time series ingestion? From Sui Abraham.
That's an interesting question. That there's actually a database, a relational database that's called Timescale. That they are precisely with Postgres. They have a time series database, and it's a quite interesting project and database. So that was done. Would I still use it? Well, I can only paraphrase what Timescale is doing, and it's not my ideas, but they are, what they claim is that SQL still has an interface that people are used to. It's the technology that people are used to, and if you can solve the problem of, can have like a storage that performs really well with for instance time series, that case, then they made it work and it works. So something to have a look